Hello everyone, my name is Atinoke Fasea. I'm your chemistry tutor for the ISPAK prep class. So today we'll be looking at periodic table and chemical reactions. So let's look at periodic table first. Periodic table is the most important classification of elements in chemistry. It shows the arrangement of elements based on certain factors, their atomic numbers, and their electronic configuration. We have different groups on the periodic table. If you can, like you see, we have groups, we have periods, these are groups, and these are periods. So we have 8 groups on the periodic table, and they are all families. They are all families. So let's quickly look at each of the family before we move on. Group 1 are alkali metals. We have sodium, lithium in that group. We have potassium in that group. You have one valence electron on their shell, and they donate that valence electron, and this makes them a good reducing agent. They are good conductors of heat and electricity, and they are univalent. So they form one positively charged ion. Group 2 alkali metals, example calcium, magnesium, strontium. They have 2 electrons in their outermost shell, and they are divalent. They are good reducing agents as well, and reactivity increases down the group for metals generally. Reactivity increases down the group for metals. We have group 3, which have 3 valence electrons on their last shells. They are trivalent, and they are reducing in nature as well. We have group 4, they are tetravalent. That means they have 4 valence electrons on their last shell. They tend to form covalent compounds, and their metallic property decreases down the group. So when you go down group 4, you realize that carbon and silicon are non-metals. Then as you go down, you see tin, lead, which are metals. So they change from being non-metals to metals on the group, down the group. We have group 5. They are non-metals, that's nitrogen, phosphorus are in that group, and they have 2 common valences, 3 and 5, but they also form other valences. They can exist from 3, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, 5. They are electron acceptors because they are non-metals. Then we have group 6. A very good example of group 6 elements are oxygen and sulfur. They are electron acceptors because they are non-metal as well, and they are good oxidizing agents. Then we have group 7, which are known as the halogens. They are all non-metals. We have chlorine, fluorine, bromine, iodine, astatine in that group. They exist as the atomic molecules. So you have Cl2, F2, I2. They are colored as well. They are colored. They ionize to form univalent negative ions. Then we have group 0 or 8. They have no bonding electrons in the outermost shell, hence the group is named 0. They exist freely, and their boiling point decreases down the group. We have transition elements. Transition elements, the elements in the D block, and they are partially filled. Their D block, their D orbital are partially filled. We have scandium, titanium, vanadium, chromium in that group. Then we have others known as lanthanines, which are rare earth elements, and we have actinides as well. They are placed in the 7th period of the periodic table. Let's look at types of chemical reactions. You know, chemistry is all about reactions, so we have a lot of reactions in chemistry. Now let's look at this. We have types of chemical reactions. We have synthesis, decomposition, single displacement, double displacement, complete combustion, incomplete combustion. So under synthesis, we have direct combination of 2 metals forming compound. We have decomposition, splitting apart of a compound to give 2 different items. We have single displacement based on reactivity series. Elements are displaced. the more reactive element displaces the less reactive element. We have double displacement. We have combustion reaction, and we have incomplete combustion. Combustion reaction, complete combustion will give you carbon 4 oxide and water. Incomplete combustion will give you carbon 2 oxide and water. There's a very important part of the reactivity of chemistry known as reactivity series, which you can see here. The more reactive elements are placed higher, and the series is about how reactive elements or cations are. So we have the calcium, potassium, calcium, sodium has been very reactive, while the zinc, aluminum, magnesiums are moderately reactive, and we have copper, lead, silver, gold, mercury that are less reactive. Other types of reactions, we still have exothermic and endothermic. Exo gives out heat, endo takes in heat in reactions. We have oxidation, reduction, the both of them are known as redox. We have combination, decomposition, and like I said, we have displacement reaction. Let's look at oxidation and reduction. As the name implies, oxidation is gain of oxygen, while reduction is loss of oxygen. Oxidation is loss of hydrogen, reduction is gain of hydrogen. In terms of electrons, oxidation is loss, reduction is gain. Look at this can be used to remember. Oxidation is loss of electron, they call it oil rig, and reduction is gain of electron. These two reactions coming together is known as redox. So a redox reaction is a reaction whereby reduction and oxidation are going on simultaneously in that reaction. We also have reducing agent that brings about reduction, and oxidizing agent that brings about oxidation. So we'll be seeing this in some questions, and I will be explaining further on it. Oxidizing agent is a substance that is reduced in a chemical reaction, thereby bringing about oxidation, while reducing agent is a substance that is oxidized, thereby bringing about reduction. It will remove oxygen from other substances. And we have water that acts as both oxidizing and reducing agents. We have stoichiometry, mass volume relationship. Stoichiometry deals with the definite ratios in which substances combine, and we have different ways in which substances combine. There are some terms we need to understand, we need to remember. Molar mass of a substance, we look at the mole of substances, your relative molecular mass, which is expressed in grams. Now, a mole is of a substance, the amount containing as many elementary entities as number of atoms in exactly 12 grams of carbon-12, and which is also equivalent to 6.02 times 10 raised to the power 23, which is known as the Avogadro's number. We have the mole concept. The mole concept can be expressed in different ways. One is number of moles reacting mass over molar mass. That's a very unique formula that I hold dearly to my heart. Then we have 1 mole, which is also equivalent to RMM or RAM, that's relative atomic mass or relative molecular mass. We have 1 mole, which is equivalent to Avogadro's number, or you can say atoms, ions, electrons, protons, or molecules. And the constant is 6.02 times 10 raised to the power 23 atoms. Then we also have 1 mole equivalent to 22.4 dmq at STP. These are things I know you know, so let's look at some questions under it, then we explain more on this. This is like a brief reminder on mole concepts. The molar volume of a gas can be defined as the volume occupied by 1 mole of the gas at standard temperature and pressure, and that value is 22.4 dmq or 22,400 centimeter cube at STP. I've explained this earlier. Mole concept in terms of formula, in terms of relative molecular mass, in terms of Avogadro's number, in terms of molar volume. These are ways in which moles can be expressed, and they are known as mole concepts. Now it's time for questions. It's time for questions. It's time for questions. So let's take out your book and let's see how far we can go. Let's remind ourselves how far we can go. Let's remind ourselves. Okay. Moving on. Get your book, get your pen. Let's start. What is the oxidizing agent in the reaction below? We have lead-2 sulfide reacting with hydrogen peroxide to give us lead-2 tetrahydrosulfate 6 and water. So what is the oxidizing agent in the reaction below? Okay, I said earlier that oxidizing agent is one that brings about oxidation. So let's have our answer, hydrogen peroxide, which is B. Hydrogen peroxide is the answer. Okay, and why is that so? Why is that so? Let's look at it. If you look at this reaction properly, you realize that lead-2 sulfide is the reducing agent, while hydrogen peroxide is the oxidizing agent. Hydrogen peroxide is the one giving oxygen to lead-2 sulfide to become lead sulfate, while hydrogen peroxide is reduced. So oxidizing agent is being reduced, while reducing agents are being oxidized in reactions. What's the function of ammonia in the reaction? We have ammonia reacting with copper 2 oxide to give copper, water, and nitrogen. So they're asking us the function of ammonia in this reaction. The answer is reducing agent. If you look at it properly, you realize that copper oxide is the one adding oxygen to nitrogen. To hydrogen, sorry. Copper 2 oxide is losing oxygen. So ammonia is a reducing agent, while copper 2 oxide is the oxidizing agent in this reaction. Look at this reaction. Even if you look at the electron, you realize that by the time you split this into two, this gives us copper 2, and here we have copper 0. Yes, this is 0. So plus 2 going to 0, that's reduction. Plus 2 going to 0 is reduction. And minus 3 going to 0 is oxidation. Yes, is oxidation. So CuO is the oxidizing agent, while ammonia is the reducing agent. Okay. What's concentration in mole per dm cube of a solution containing 4 grams of sodium hydroxide per 20 centimeter cube of solution? Sodium hydroxide is 40 grams per mole. So give it some seconds to calculate it. So see if you will get the answer. Okay. And our answer is 5 mole per dm cube. That is our answer. Now, how did we get this? Let's see how this is done. So we have 4 grams in 20 centimeter cube. What is in 1000? 1000 will be 200. And you have your number of moles equal to reacting mass over molar mass. So the reacting mass there is 200 over the molar mass, which is 40. Then you have 5 as your answer. A reaction which has the potential to occur without the assistance of any external agent is called what? Spontaneous or non-spontaneous. So the answer is spontaneous reaction. That is our answer. Spontaneous reaction is that reaction which has the potential to occur on its own without the assistance of any external agents. We have factors that determine spontaneity of a chemical reaction. We have enthalpy, which is your delta H. We have Gibbs free energy, which is your delta G. And we have entropy, which is your delta S. How many molecules are in 5.2 mole potassium chloride? How many molecules are in 5.2 mole potassium chloride? Let me give you a few seconds to calculate your answer so that you can attempt it on your own. So we have our answer to be 3.13 times 10 raised to the power 24 molecules. And how is that so? Let's see. How do we get that? We take 1 mole to be 6.02 times 10 raised to the power 23. Then 6.02 times 10 raised to the power 23 times 5.2 mole of potassium chloride. And your answer will be 3.13 times 10 raised to the power 24 molecules. What is the value of X in the reaction given? What's the value of X in the reaction given? That's tetraisosulfate 6 acid reacts with potassium hydroxide to give you potassium tetraisosulfate 6 plus water. So what's the value of X in the reaction given? So that's you balancing that reaction. So what do you think the answer should be? And our answer is 2. Because on the product side you have potassium K2, so definitely this will have to be 2 to balance the reaction. What pressure will be required to compress 200 centimeter cube of oxygen at 400 millimeter per mercury to 100 centimeter cube, temperature remaining constant? A 600 milliliter per mercury, 700 milliliter per mercury, 800 milliliter per mercury, 500 milliliter per mercury. Give you a few seconds to calculate so that you can get your answer. Attempt it on your own. So our answer is 800 millimeter per mercury. And how do we get this? Let's see how this is being done. So using Boyle's law, make your P1 the subject of the formula, substitute your values, and you have your answer to be 800 millimeter per mercury. How many moles of oxygen will contain 1.806 times 10 raised to the power 24 molecules? Avogadro's number is 6.02 times 10 raised to the power 23. So how, quickly, can you give us the answer? Okay, very good. I can see that a lot of us are trying, attempting to give us the right answer. And the answer is 3. Yes. How do we go about this? How did you get it? Let's see. 1 mole of oxygen is equal to 6.02 times 10 raised to the power 23. So what will be 1.806 times 10 raised to the power 24? So if you do your calculation, you have 1 times 1.8, 1 times 1.806 times 10 raised to the power 24 over 6.02 times 10 raised to the power 23 to give us 3 moles. 3 moles of oxygen. What does X stand for in the following reaction? This is one of the most common reaction you can ever come across in chemistry, and without thinking twice, you should know that your answer is water, H2O. This is a neutralization reaction, so direct, so straightforward. Hydrochloric acid reacts with sodium hydroxide to give sodium chloride and water only. If you remember, the definition of neutralization reaction is what I just said. Reaction of acid plus base to give salt and water only. What's the quantity of electricity required to discharge 1 mole of univalent ion? Univalent means 1 charge plus 1 plus. So what's the quantity of electricity required to discharge 1 mole? 1 mole is equivalent to 96500, and that is our answer, 96500 C. Now it's good to know this. It's good to know this, that when you are dealing with 1 mole of electron, this could be silver, gold, sodium, potassium. It is always 96500. When you are dealing with 2 moles of electron, it's 193,000 coulombs. which could be copper, zinc, lead, hydrogen, and chlorine. If you are dealing with 3 moles of electron, that's 289,500 coulombs. We are looking at aluminium or chromium. And when you are dealing with oxygen, it's always 386,000 coulombs. So familiarize yourself with it and let it stick, so that anytime you need it, you quickly get it. What's the percentage by mass of carbon in calcium triisocarbonate 4? Formula for calcium triisocarbonate 4 is CaCO3. And by the time you look at the percentage by mass of carbon, you should be able to get this. An easy question as well, and your answer should be 12%. How do we get that? Let's look at it. Like I said, the formula for calcium triisocarbonate 4 is CaCO3. So the first thing you do is calculate the RMM, and your RMM is calcium is 40, carbon is 12, then oxygen is 3 times 16, then you have 100. Formula for calculating percentage composition by mass is you put the element you're looking for over the total, which is the RMM, times 100. And substituting your value, you have 12 times 100 over 100, and your answer is 12%. Calculate the mass of water produced when 12 grams of hydrogen react with excess oxygen. How do you do that? The first thing to do is to write the reaction. Okay, let me give you a few seconds to look at that question and give me the answer. Let's see. Okay, so let's look at the percentage by mass of carbon in calcium triisocarbonate 4. The formula for calcium triisocarbonate 4 is CaCO3. So the answer is 12. So how do you go about this? The first thing you need to do is to calculate the RMM of calcium carbonate. That's 40 plus 12 plus 16 times 3, which is 100. Then you have your carbon over the total times 100. Then you also have substituting your value, we have 12 times 100 divided by 100, and your final answer is 12%. Now, moving on to the next question. Calculate the mass of water produced when 12 grams of hydrogen react with excess oxygen. Okay, let's see. How do you do that? How do you do that? Let me give you a few seconds to look at the answer, to tell me the answer. Okay, good. So what did you get? 108 grams. Mark yourself if you have gotten the right answer. And do we do that? Let's see the answers. Let's see how it's being done. To calculate this, the first thing to do is to write the equation for that reaction. When you write the equation for the reaction, you realize that using the relative molecular mass, hydrogen is 4, that's 2 times 2 will give you 4, and water is 18, 18 times 2 will give you 36. So if 4 is reacting with 36, what will 12 react with? So you have your 12 times 36 over 4 to give your final answer as 108 grams. Okay, calculate the volume of oxygen produced from the decomposition of 4 moles of KClO3 at STP. Molar volume of a gas at STP is 22.4 dmq. So what do you think the answer is? Can you be calm to answer the question? Okay, give you a few seconds to look at it. Okay. No, what did you get? What's your answer? Okay, the answer is 134.4 dmq. And how do you go about this? How do you solve this question? The first thing you need to do is to write the decomposition of potassium triisochlorate 5. That's the first thing you need to do. Now, if you balance the reaction, realize that the reaction is ratio 2 to 2 to 3. And what you are asked to do is to calculate the volume of oxygen. So 2 moles of potassium triisochlorate 5 is reacting with 3 moles of oxygen. And molar volume of gas at SCP is 22.4 dmq. So the molar volume of the gas, which is oxygen, is 22.4 dmq, and the mole ratio in front of oxygen is 3. So you have 3 times 22.4 dmq. So if 2 moles of KClO3 is giving 67.2 dm³ of oxygen, the 4 moles of KClO3 will give 67.2 times 4 divided by 2, which is 134.4 dmq. Did you get that? Okay, let's move on to the next question. What is the number of moles of limestone that will be required to produce 4.4 grams of carbon dioxide? Taking calcium to be 40, carbon to be 12, oxygen to be 16. Okay, it's similar to that other question. So give you a few seconds to look at it. Then we look at the answer together and how the answer is. Okay. Our answer is 0.10 mole. But how did you get it? The first thing you need to do is also to write the reaction of the decomposition of calcium triazocarbonate 4. Calcium triazocarbonate 4 decomposes to give you calcium oxide and carbon 4 oxide. So having that in mind, then the number of moles, we are only looking at CO2, carbon 4 oxide. So number of moles is reacting mass over molar mass. The reacting mass is 4.4 grams, while the molar mass of carbon 4 oxide is 12 plus 2 times 16. That gives us 44. So we have 4.4 divided by 44, then our answer is 0.1 mole. Now the next question, what is the percentage by mass of oxygen in ammonium triazonitrate 5? Ammonium triazonitrate 5. We're looking for the mass of oxygen in it. Okay, so how do you solve this question? The first thing you need to do is actually to calculate the relative molecular mass of ammonium triazonitrate 5. But what did you get as the answer? Okay, the answer is 60%. Did you get it? Okay, let's look at it. How we have 60%. So you calculate the relative molecular mass of ammonium triazonitrate 5 to be 14 plus 4 times 1, because we have 4 hydrogen, 4 times 1 plus 14 plus 3 times 16. So having that at the back of your mind, by the time you calculate, you have 80. That's the relative molecular mass of ammonium triazonitrate 5 is 80. Then the formula is 3 oxygen over the total times 100. And your oxygen is 48. That's 3 times 16 times 100 over 80. And your final answer is 60. That's beautiful. Moving on to the next question. What is the role of manganese 4 oxide in the reaction represented below? Okay, that's manganese 4 oxide plus hydrochloric acid to give us manganese 4 chloride plus chlorine and water. This is one of the laboratory preparation of chlorine. So in this reaction, you are being asked to give the role of manganese 4 oxide. And as you can see clearly, is an oxidizing agent. Manganese 4 in this reaction is an oxidizing agent. Like I said earlier, the oxidizing agent brings about oxidation, and the reducing agent brings about reduction. You realize oxidizing agents are being reduced while reducing agents are being oxidized in reaction. Okay, so the manganese 4 oxide is being reduced, manganese plus 4 is being reduced to plus 2, and that is why it's an oxidizing agent. What's the value of Y in the following equation? This is an equation, if you have done with us, should stick to you so fast. It's one of the major examples of reduction reaction that happens at the cathode during electrolysis. And without wasting time, the answer is 5. You should be familiar with this question. Very familiar with it. Okay, so the complete reaction is this. That's manganese 4 ion plus 8 hydrogen ion plus 5 electrons to give manganese 2 ion plus water. Which of the following processes is an example of neutralization? We've said earlier that neutralization reaction is reaction between acid and base to give salt and water only. So if you look at all the options, which one do you think is an example of neutralization reaction? Without wasting your time, the most effective and the right answer is liming of soil. Liming of soil is a neutralization reaction. Okay. What happens to the pressure of a closed gaseous system when the temperature increases twofold? 10 minutes. What happens to the pressure of a closed gaseous system when the temperature increases twofold? Pressure is reduced, pressure remains constant, pressure is doubled. Increases twofold. So what do you think the answer is? The answer is pressure is doubled. That's the answer. The answer is pressure is doubled. This law shows a direct relationship between temperature and pressure. As temperature increases, pressure will increase proportionally. What type of reaction is represented as follows? Zinc triazocarbonate 5 decomposes to zinc oxide and carbon 4 oxide. Saying the word equation alone tells you the answer. So the answer is decomposition reaction. It is neither oxidation nor reduction, or it is not neutralization. So the answer is decomposition reaction. I hope you are looking at your answers. I hope you are getting it. The expression PV over T describes, what does it describe? What comes to your mind when you hear this? Is that this gas equation, and is the combination of Boyle's law and Charles' law give you that reaction. What's another term for a decomposition reaction? Another term for decomposition reaction. Is it precipitation? Is it dissociation? Is it displacement or oxidation? So the answer is dissociation reaction. Dissociation is another term for decomposition reaction. Others are types of reactions. We have precipitation, we have displacement, and we have oxidation. What process could be used to describe the conversion of manganese 7 ion to Mn2+? Okay, let's look at it. If you are decomposing manganese, yes, that's tetraoxomanganese 7 to manganese ion. What happens? What was the conversion? Now, if we calculate the oxidation state of manganese in manganese tetraoxomanganese 7 ion, you realize that the oxidation state of manganese is +7 here. Why this is reduced to 2+? So the answer is reduction. Reduction is used to describe the conversion of tetraoxomanganese 7 ion to manganese 2 ion. Reduction. Okay. What is the product of the reaction of hydrogen peroxide with chlorine? What is the product of the reaction of hydrogen peroxide with chlorine? You can write the reaction so that you can get the answer. Try writing out the reaction. Hydrogen peroxide with chlorine. Hydrogen peroxide with chlorine will give you hydrochloric acid and oxygen gas. Hydrochloric acid and oxygen gas. Hydrogen chloride and oxygen gas. This is one of the reactions of chlorine. It's one of the reactions of chlorine. When hydrogen peroxide reacts with chlorine, it forms hydrochloric acid and oxygen gas. The two components of water gas are, yes, you should remember water gas. We have water gas, we have producer gas. There are two types of fuel. So under carbon. So what are the components? For water gas, we have carbon 2 oxide and hydrogen gas, while for producer gas we have carbon 2 oxide and nitrogen gas. Water gas is more combustible than producer gas. Water gas is more combustible than producer gas. What is the stoichiometry ratio of acid to base in the reaction represented as hydrochloric acid reacting with sodium hydroxide to give sodium chloride and water? If you look at this reaction, what they need you to do is to balance the reaction. So in what ratio is the acid reacting to the base? It's a direct question, very easy as well. It is ratio 1:1. By the time you balance the reaction, realize that the reaction is balanced, and the ratio of acid to base is ratio 1:1. Which of these factors, now we're going to periodic questions. Let's see periodic table questions briefly. So which of these factors does not affect ionization energy? Does not affect ionization energy. Ionization energy is the minimum energy required to remove the most loosely bound electron in a shell. Now, we have screening effects of the inner electrons, the distance of the outermost electron from the nucleus, the size of the positive nuclear charge, and the number of orbitals. So the one that do not affect ionization energy is the number of orbitals. Number of orbitals do not affect ionization energy, but others are factors that affect ionization energy. We have the distance of the outermost electron from the nucleus, we have the size of the positive nuclear charge, the screening effect of the inner electrons, and the screening effect is when valence electrons are shielded from the positively charged nucleus by the electrons in the core electron shells. Amount of effective nuclear charge is also a factor that affects ionization energy of an atom. The following properties increase across the period. We have trends of periodic table, trends of periodicity. We have ionization energy, atomic radius, electron affinity, electronegativity, metallic character. We have ionic radius, and I think that's all. So this trend, some increases down across the group, some decreases across the group, some across the period, and some decreases down the period. So it depends on the property you're looking at. So this question is asking which one increase across the period. Is it ionization energy, atomic radius, electron affinity, or electron negativity? The answer is atomic radius. Atomic radius do not increase across the period. Rather, it decreases across the period. Now, I think I have a table here that can help you remember, the trends of periodicity. So you look at electronegativity increases across the period but decreases down the group. Electron affinity increases across the period and all decreases down the group. Atomic radius decreases across the period and increases down the group. Ionic radius decreases across the period and increases down the group. Ionization energy increases across the period and decreases down the group. What is the period of the element whose electronic configuration is represented as follows? 1s2, 2s2, 2p6, 3s2, 3p6. The first thing you first have to look at is what element are we looking at? The element is, we have 18, so the element should be the 18th element, which is argon. Argon is the 18th element. So what period of the element, what period is it? How do you know period? Now, before we look at how periods are being seen or identified in electronic configuration, let's see your answer. Our answer is 3, is on period 3. Now, how do you achieve that? Let's see it in this illustration. If you look at this illustration well, the first shell, which is 1s2, can only take 2 electrons, and that's what you have here, can take 2 electrons, while the second shell, which is 2s2 2p6, can take 8 electrons. That's what you have here. 2 plus 6 is 8. Then the third shell really can take 18 electrons, but what is given is 3p6. So now look at it. This is the third shell, 3s2 and 3p6. So since it's the third shell, that means it's on period 3, because number of shells determines the number of period, the period where an electron is likely to be found. The number of shell will determine it. So the figures in front will tell us the shell number, while the superscripts will tell us the valency of the element. So the answer is 3. To which group and period respectively does an element with 14 electrons belong? Okay, let me give you 1 second to quickly look at that. To which group and period respectively does an element with 14 electrons belong? Okay, our answer should be 4 and 3. Then how do we look at that? How do we do that? Let's see in this illustration. If you look at the electronic configuration of this element, which is a silicon, that's the 14th electron, the first shell, the second shell, and this is the third shell. And I told you that number of shells determine the period. So because it's in the third shell, it is on period 3. Now this third shell, add these two numbers together, we give you 4. That is to tell us that it's in group 4 of the periodic table. Or you look at the number of the valence electron. The last electron is known as valence shell. And how many electrons are on the valence shell? We have 4. 1, 2, 3, 4. That tells us the group number. So if it's 1, it's group 1. If it's 2, it's group 2. So this is 4. It's telling us that it's in group 4. So the answer is 4 and 3. The element in the periodic table that gains electrons most readily belongs to, which is there, what element in the periodic table gains electron most readily? If you agree with me, you realize that non-metals are the ones that gain electrons, while metals lose electron. So what do you think the answer is? Our answer is group 7. Group 7 are the ones that most readily gain electron. Like I said, metals lose electrons, while non-metals gain electron. Okay. To which block in the periodic table does 12 magnesium belong? To which block in the periodic table does 12 magnesium belong? Now we have different blocks. We have S block, P block, D block, we have F block. So which one does magnesium belong? The answer is P block. Oh, sorry, the answer is S block. The answer is S block. Now let's see. Let's see how we can know which one is belonging to a particular one. Now look at the color code to learn SPDF block. The light green is S block, which is the 2 columns here. The purple is P, You can see the purple color here. Then the D is the pink, that's the D transition block. Then we have the F, which has the lanthanide and antiactinides, that's the F block. So we have the S, P, D, F. S, P, D, F blocks. The energy required to remove 2 electrons from 3s orbitals of gaseous magnesium atom is called. Direct question. The answer is ionization energy. Ionization energy is the energy required to remove 2 electrons from gaseous magnesium atom. Is the minimum energy required to remove 1 mole of an electron from 1 mole of gaseous atom to form 1 mole gaseous charged ion. That's ionization energy. Which of the following determines the position of elements in the periodic table? How do you know the position of elements in the periodic table? Is it the nuclear number, the number of protons in its atom, the number of electrons in its atoms, or the number of neutrons? The answer is the number of protons in its atom. The number of protons is also known as atomic number, and that is how electrons are being arranged on the periodic table. That's how electrons are being arranged. Which of these elements has the largest atomic size? Which of these elements has the largest atomic size? In short, they're asking us that which one is the biggest. Which one is the biggest? How do we know the biggest? How do you know the size of an element? It has to do with the atomic number. If you look at it, the answer to this question should be cesium. Cesium is the answer. And the atomic number for sodium is 11, lithium is 3, potassium is 19, and cesium is way bigger than all of them. So that is how to know the largest, or how big an atom is. The number of orbitals in a p sublevel of an atom is. What's the number of orbitals in a p sublevel of an atom? The answer is 5. The answer is 3. Sorry, the answer is 3. And let's see, for S. Okay. For S, the number of orbitals is 1, and 2 electrons can go in. Then for P, number of orbitals is 3. Then we have 6 electrons going. Then for D, number of orbitals is 5. Then we have 10 electrons. And for F, we have 7 orbitals, and number of electrons going in is 14. Which of the following halogen is the most reactive? Let me tell you that reactivity in the non-metals decreases down the group. Reactivities in non-metal decreases down the group, making the higher ones more reactive than the lower ones. So if you look at this question very well, you realize that the most reactive halogen should be fluorine. The answer is fluorine. So fluorine is the most reactive halogen, because like I said, reactivity decreases down the group in non-metal, and halogen is a non-metal. Halogens are non-metals. In the periodic table, all the elements in the same group have the same A shells, B protons, C valence electrons, D neutrons. What do they have? They have the same valence electrons. Elements in the same group have the same valence electrons, and that's why they behave the same way by going to reactions the same way. they have the same valence electrons. Which of the following is not an alkaline earth metal? Yeah, group 2 members are alkaline earth metals. So which one is not in group 2 in this question? The answer should be lithium. Lithium is the only element here that is in group 1. Others are in group 2. Others are in group 2. Group 7 elements are also known as, what are group 7 elements known as? They are known as halogens. That is so easy. Group 7 elements are known as halogens. Group 8 are known as noble gases or rare metals, rare elements. What is the group of the elements whose electronic configurations is represented as follows? 1s2, 2s2, 2p6, 3s2, 3p3. What's the group of the elements whose electronic configuration is represented as follows? We have looked at this before, and you should be you should familiarize yourself with it. You should be familiar with it by now. So what is your answer? The answer is 5. Yes, because we said that you had 3 plus 2 will give you the number of the valence electron of that element, and valence electron will tell you the group of the elements, will give you the group of the elements. Which group does an element having the lowest electronegativity in the periodic table belongs? Which group does an element having the lowest electronegativity in a periodic table belongs? The answer is group 1. Group 1. Let's see. Elements with the lowest electronegativity are located at the bottom left corner of the periodic table, such as group 1 metals like cesium. Now, electronegativity increases across the period and decreases down the group. So you can find lowest electronegativity on this side. You find lowest electronegativity on this side. Which of the following atom is the smallest? Which of the following atoms is the smallest? This is so easy. The answer is lithium. Lithium is the smallest because of the atomic number. It's the smallest because of the atomic number. Which of the following values will decrease as you move left to right in a period of the periodic table? In a period of the periodic table, which one will decrease as you move left to right? We have metallic character, we have ionization energy, electron affinity, and non-metallic character. The answer should be metallic character. Why? All others will increase. Why only metallic character will decrease? All others will increase. Only metallic character will increase. As you can see in this diagram, ionization energy decreases across the period. Electron affinity decreases. Non-metallic character decreases. but metallic character, all others increases, metallic character decreases, as you can see in this diagram. How many valence electrons does phosphorus have? I've already given you the electron shell, which is 285. So how many valence electrons does phosphorus have? Phosphorus have 5 valence electron. That's 5 valence electron. Which group is in the periodic table is associated with noble gases? Group 0. They do not give or take, and the electron, they have an octet structure, they are complete, all the valence shell is complete, so they don't give, they don't take, they don't go into reactions. They are groups, that is called them group 0 or group 8. They are called noble gases. The following are metals except calcium, magnesium, and tungsten are metals. Only phosphorus is not a metal. Phosphorus is a non-metal. The group of elements in the periodic table that are chemically inactive. I just said it, that noble gases do not react. They are chemically inactive because they do not give out and they do not take in electrons. Their shells are completely filled up. They're completely filled up. Others are active. Thank you. That's the end of the class. Thank you so much.